If you just picked up the brand new Intel Core Ultra 7 270K Plus for your next production workstation, do not touch your BIOS settings until you see this data. Most people buy a 24-core unlocked processor, throw it into a high-end motherboard, and instantly start worrying about the stock voltage profiles melting their silicon, or losing rendering performance right out of the box. Today, I'm putting an end to the guessing games, and I'm skipping the manual tuning entirely, loading up the factory stock profile, default XMP settings. And I'm putting this chip through a brutal, real-world creator workload to see exactly how it handles stock thermals and out-of-the-box diagnostics. What's up, everyone? It's the Don with the Don Tech, and tech is my business. For nearly 2 decades, I've built, repaired, and diagnostically tested over 20,000 PCs in the field. So when a brand new refresh platform lands on my bench, I don't care about theoretical marketing sheets. I only care about what happens when you actually put it through its paces and to see how it can perform for me. To keep this diagnostic process and testing process completely pure, I'm housing this chip in a hardware configuration built exactly for high-tier long-term reliability. I'm utilizing my personal rig, the ASUS ROG Strix Z890 gaming Wi-Fi motherboard, as my core platform for the system. For memory, I'm not committing any crimes here. I have a massive 96 gig kit of G.Skill Trident Z DDR5 RAM running at an extremely stable 6400 MHz with the default XMP profile enabled. My storage is pinned to a bulletproof 4TB Samsung 990 Pro NVMe drive, and my main graphical engine is the brand new PNY RTX 5070 12 gig card. Cooling the entire system is the Corsair RS360 all-in-one liquid cooler running straight off the motherboard headers. I have no extra bloatware, no clunky software, just pure hardware capabilities. Now, cleanly delivering the juice to this 24-core CPU and a high-end discrete graphics cards requires an absolute powerhouse of a foundation. If your power delivery is unstable, your benchmark metrics will instantly skew due to voltage ripple and micro stuttering. And to guarantee absolute cross-platform runtime reliability on my bench, I'm backing this configuration with my personal Corsair AX 860-watt titanium-rated power supply. And by protecting the platform electrically, I'm making sure that the motherboard can precisely allocate clean, stable wattage straight to the silicon socket under the maximum computing stress. I think. Raw performance means absolutely nothing if the chip is actively cooking itself inside the socket. And to trace the baseline health of this platform, I log the full thermal and electrical envelope inside of Hardware Monitor. Sitting just in idle, the processor itself runs at an incredibly comfortable 33 degrees Celsius. But when you lock it down under a sustained 100% all-core multi-threaded execution loop inside a Cinebench, the temperatures tell the real story of Intel's Arrow Lake refresh architecture. The core package peaked at about 77 degrees Celsius, which is insane. And let's break that down. On older flagship generations, throwing an all-core heavy multi-threaded compute task at a stock CPU would instantly send the core packages rocketing straight into the 90s or right into the 100-degree thermal velocity threshold. But because of my Corsair 360mm radiator, it's moving all of that heat efficiently. And because the specific 270K Plus architecture is pulling a highly controlled maximum package power of just about 200 watts at the rail, I have an ocean of thermal headroom left on the table. It proves that out of the box, Intel has reined in the catastrophic power scaling of the past. For the data enthusiasts who want the raw diagnostic numbers to cross-reference for their own test benches, here's exactly how the numbers stack up. In Cinebench, the raw GPU metrics landed about 56,345, with the CPU pounding out the multi-threaded score of 9,495 and a single-thread response of 552. When I shift over to the raw Blender rendering computer test, the CPU handles the workload seamlessly, pulling 1,983 on Monster, 1,367 on Junk Shop, and 1,156 on Classroom. The dedicated PNY 5070 GPU tracks right alongside it, logging 273 on Monster, 206 on Junk Shop, and 145 on Classroom. Moving into 3D rendering environments with Superposition, the system shows its architectural bandwidth. At 1080p Extreme, I secure a score of 13,656. I push the resolution to the 4K optimized, and it scales cleanly to 17,646. Even when I force it to an absolute 8K optimized data crunch, it holds its ground at 6,877. And for real-world gaming workloads at 1440p inside of Cyberpunk 2077, the stock out-of-the-box configuration delivers an incredibly responsive fluid baseline, averaging a flat 65 frames per second and a maximum frame capping at my 100 frames for my 100 Hz display. My minimum dips were right around the 33 frames per second as well during the heavy engine asset scaling during that benchmark testing. If you follow my channel, you know that I've done a video on how to build the ultimate PC. I loaded the timeline inside Premiere Pro, and this exact same massive project file from my ultimate PC build guide video. By the way, if you haven't seen it, definitely check it out, it'll be in the description down below. That folder is packed with raw multi-camera 4K tracking timelines and relentless layers of nested graphical overlays. On a standard older mid-tier system, throwing a 171 gig project folder directly into Premiere Pro export pipeline is usually where the system completely folds in half. But if you watch this, I hit direct export to compress it into a clean, highly optimized 15 gig delivery package, and I let that 270K plus chew through it at complete factory stock settings. And the result? It spit out the finished file in exactly 14 minutes flat, give or take a few seconds. So think about that math. A massive, heavy, multi-cam creator workspace processed down to a rate of less than 13 seconds of raw computing power required for every single minute of footage on the timeline, if my math is correct. That is absolute brute force architectural efficiency without making a single adjustment inside the UEFI. If you're getting value from these real world tests, do me a quick favor, smash that subscribe button and drop a like. It really helps the channel grow. And plus, I've got a full series breaking down this entire platform from every single angle, and you don't want to miss the efficiency, longevity, and head-to-head videos coming up. So here's the baseline verdict from 2 decades in the repair trenches. If you're building a modern workspace, you do not need to stress about instant manual optimization or messing with the custom voltage curves to keep your platform stable. The Core Ultra 7 270K Plus on this ASUS Z890 platform delivers complete operational stability, massive creation compute speeds, and incredible safe thermal profiles straight out of the box. And that's exactly what you want for longevity. Drop a comment down below if you're running this exact setup, or let me know what numbers your rig is currently pulling. Thank you so much for watching this video. This has been the Don with the Don Tech, and remember, the Don's got your back.